you again for joining us. Welcome to our webinar on how you can add intelligence to your sewer inspections. I'm Catherine Brill. I'm the BRYX product manager at KCI Technologies, and I'll be leading today's webinar. And I'm joined today by my colleagues, Carl Keller. He is a senior systems engineer. He's also the leader of our machine learning operations team. And I'm also joined by Jay Kwan, our sales engineer. It's our pleasure to talk to you today about the evolving role of AI in the wastewater industry. So to get started, our goals for this webinar are to review the industry standards for sewer pipeline assessments and explore how AI can be used to transform those assessments, and then also demonstrate BRYX AI solutions for sewer defect detection as well as automated repair recommendations. Here is a brief overview of the state of our wastewater infrastructure today. We have approximately 2.2 million miles of sewer pipes in the United States. Unfortunately, the last grade that we got from the ASCE's 2025 infrastructure report card was a D+ for wastewater. And it's estimated that there's about a $99 billion annual investment gap for water infrastructure in our country. And poorly maintained sewer pipes have a direct and immediate impact on so many different aspects of our daily lives. When a sewer pipe fails, there can be traffic delays, loss of service, property damage, environmental hazards, risks to our health and safety, and also there's financial burdens, including having to hire emergency personnel for repairs and also having to pay substantial EPA fines. So sewer pipeline assessments are critical to maintaining our underground infrastructure. I want to briefly go over what is a common approach to conducting pipeline assessments. Typically, a utility will hire an inspector to use a special robotic crawler system to go down through the pipe and capture data. And this involves a skilled operator on a truck guiding the camera and then labeling the defects found in real time using industry standards that have been established by NASCO. Then the next stage is that video must be reviewed to check for the quality of the labels. Were any defects missed? Were any defects misclassified? And this involves staff reviewing hours and hours of video, which is a very time-consuming, tedious task. In the next step, the standard exchange PACP database, which is part of the inspection data that is delivered, needs to be reviewed. And this file includes coded classifications, ratings, grades, and metrics for the inspection. From all of this data, a list of recommendations for remediation is created, along with cost estimates for those repairs. And then the utility or municipality can use those ranked recommendations to prioritize their maintenance activities and also budget for repairs. Coding sewer pipelines and analyzing inspection video poses a variety of challenges. I've listed some of them here on this slide. Time-consuming manual review of that inspection data, potential for inaccurate defect coding, as inspectors might miss pretty severe defects, the difficulty in training novice inspectors, and also the difficulty in generating appropriate treatment recommendations based on the defects found during the inspection. So with that, I am going to hand it over to my colleague, Carl, who's going to talk about how AI can be used to help optimize those processes.
Thanks, Catherine. Well, I'll go into a little bit of detail about the technical approaches that we employed for each of the three primary workflow items that you see highlighted there. For defect detection support, which is how we characterize this, we use a deep neural network vision-based system. And the way that works is that we have used video data that's separated out into imagery. The imagery is then annotated by hand, coded against the NASCO defects that we targeted for this particular version of our application. The model's trained, and it's put into something called MLOps, which is our more or less our source code control, but for machine learning models. And what that allows us to do is to track the actual data sets that were used to build the specific versions of the models, which is critical for our process, since we need to know, for instance, what the models were trained on at each version. So that was selected because it gives us a very familiar target for our QA person to look at. They're going to see the same video that they would have been reviewing manually and looking for correspondence in the defects and labeling. In our system, we provide them with an output of all the defects that were tracked down the length of the pipe, as well as the highlighted detections themselves overlaid on the video. So that provides them a familiar artifact to look at, and they could be looking at it in parallel. The second part of our automation is purely computational. It's not an AI system. It's implemented in Python. We wanted to represent the grade and metric calculations that go on as part of NASCO. And so we re-implemented that in Python. The reason for that, rather than to use what might have been in the Exchange database already, is that it was determined that system wasn't under formal source code control as we understood it, and given the importance of accurate grade and metric calculations, as well as the potential for tracking modifications to those calculations, thought it best to migrate into Python and then put that under source code control using traditional programming methods. Those grades and metrics cover a select set of defects, again, that we identified from the available testing data that we use for the Exchange databases. So not a complete set of defects that we're grading, but I think a good representative set based on the test data that we had. In addition to doing grade calculations, we then proceed to the metrics calculations, which allow us then to do the third step, which is reasoning about the values of those metrics to determine what kind of recommendations and policy automation we can do. So the last step in that is a knowledge-based system, also known as a rule-based system. These systems have, basically, they represent rules as data in a network, and these rules are then applied to the data by an inference engine to produce assertions. And those assertions, in our case, are actually the recommendations that we would make that then get priced by separate code. So these knowledge-based systems are older technology than neural networks. They were sort of critical to a lot of policy automation done in the mid 90s to early 2000s. And they're still very good for that purpose. So we're not really focused on one solution to solve it all. We decided that a rule-based approach to policy automation was technically the best. So that's what we used in that area, and that's what we use to generate recommendations. We're actually looking now actively to extend the rule base that's doing that. We kind of have a version 1 knowledge base in the system currently, and it's undergoing some pretty rigorous testing that we're hoping will yield more requests for policy rules that will implement. Thanks, Catherine. Back to you.
Thank you, Carl. We developed, I wanted to go into a little more detail about what we've done on the product side, expanding on what Carl has talked about. We developed BRYX, which is a cloud platform that offers machine learning and computational models for a variety of industries, and that includes water and wastewater. And BRYX provides an optimal way for engineers, project managers, other staff in local or state government agencies, and other consultants to reduce the risk of adopting emerging technology by offering pre-trained machine learning models that are ready to run directly from the BRYX platform. They can also be seamlessly integrated with other third-party systems. So with BRYX, you can upload your data, start the BRYX model that you're interested in, and access your results all from one location. I want to emphasize that because this is an important distinction that BRYX has from other AI offerings in the market today, and what makes BRYX so valuable to our users. So instead of having to collect your data and send it to a service provider and wait days upon days for the results, with BRYX, we're providing instant analysis and complete user control over that process. So the two models that we have for wastewater, which Carl already talked about, I wanted to just emphasize again here. One is our sewer pipeline defect detection model using computer vision, analyzing CCTV inspection video and imagery, and automatically labeling the defects that it thinks it sees. And that includes broken pipes, cracks, deposits, fractures, infiltrations, and roots. The model is coding those defects based on NASCO standards. It is designed to optimize that QA/QC process while also increasing accuracy. And I do want to add that our model results are also useful as training aids for new personnel who are becoming familiar with code classification. Secondly, our smart sewer repair model uses knowledge-based system to analyze that PACP inspection database file and generate treatment recommendations automatically. This model's output provides a list of grades by codes for each pipe, along with recommended repairs, priority of the repair, and total price of the repair, and those prices can be customized for specific regions.
All right. Thank you, Kathleen. So before we jumping into the demo of our BRYX sewer model, we'd like to go over what are the value that we provide. So our solution drives operation efficiency, which directly translate to cost saving. By cutting QA and QC hours and expense, you free up resources and increase capacity without adding staff. You also gain a clear overview of your sewer pipeline conditions, making decision-making faster and smarter. The result is reduced overall cost with a minimal investment on it. So that being said, I'll pass on to Kathleen, and it will be actually showing the real product, which is the BRYX sewer model.
Okay, thank you, Jay. So let's get to show you BRYX. You should see now the BRYX interface. You access it by going to gobryx.com. The first page gives you an overview of our catalog, along with access to our resource center, which provides timely blog articles on AI topics in our industry, including wastewater. You can also access our catalog here, search by industry, so filter our catalog based on the industry that you're interested in. You can learn more about each model by clicking on the details page in the catalog card. You see here for sewer pipeline defect detection that it gives you more information about the use case, what exactly this model is trained to do, as well as required inputs and the expected outputs of the model. And also there is pricing information. One thing I want to point out here is that all BRYX models come with a free trial, no commitment required. So it's an ideal way for you to upload your own data into BRYX, run it through a BRYX model, and evaluate the results. We also offer 2 different types of licensing options. One is a subscription, and for even more flexibility, we have a pay-as-you-go option for pricing. When you log into your BRYX account, the first thing you're going to see is a personalized dashboard. This gives you more information about the model runs that you have completed, the data sets that you have processed. I see on the left-hand side of your logged in page, you have a variety of different options. One of them is data sets. When you click on the data sets page, you see all of the data that you already have uploaded to your account, and you can easily upload new data by selecting the Create Dataset button. To start a model run, you go back to your catalog and click on your Run Model button. And then it steps you through the process of configuring your model run in a wizard style display to make it as easy as possible. First thing you do is select your input that you would like to run through the model. And then you provide some parameters, give your model run a friendly name so that you can identify it later. In this particular case, I'm running the sewer pipeline defect detection model, which allows me to adjust my precision recall of the computer vision. So I can choose whether I would want the model to be very careful in its predictions or more thorough. I can adjust that when I select next. Then I get to my parameters review page. If all looks well, all I need to do is click on Run Model, and BRYX starts processing that data. One thing that I want to, when the results of this, when the model has finished processing, results can be accessed in the results page. So here you'll see all of the model runs and the results that I have generated. To access more detail, I can select on one of my results. I can download my results from this page, as well as view results. In this particular case, the sewer pipeline defect detection was analyzing CCTV imagery. And right from my BRYX user interface, I can view and download the annotated image, the results of this model run. Lastly, I wanted to show you before I get back to our slideshow, how easy it is to customize the smart sewer repair model with pricing for your region. So in this case, I've started my model run. I'm going to select a PACP database because that is the input that model requires. Select next. And here, when I get to my parameters page, you'll see I enter a friendly model run name, but I also have the ability now to customize the pricing for the repair recommendations that this model is going to generate. So going back to the slideshow, if I can, I wanted to give you an example of the output that our models are generating. This is output of our sewer pipeline defect detection model. It has been analyzing an inspection video, and as you can see, the AI is automatically detecting and also annotating the defects that are found in the video. Now, at one point, you're going to see here that the inspector, I'm going to pause the video here. The inspector has already detected a specific type of fracture longitudinal, and our models AI has also detected that same type of defect. In addition, our model also detected multiple fractures as well. So this is a perfect example of how the sewer pipeline defect detection model can be used not only to optimize and speed up the QA/QC process, but also add increased accuracy as well. Along with annotated video, this model outputs a summary report of all defects found. And you'll see in the wealth of information that this report supplies that there are all the defects found listed along with their timestamps. So that means that a reviewer, instead of having to watch the video in its entirety, can look at go to a specific timestamp to look at the defect that they're interested in, a real time saver. And then this summary report also includes total counts of all defects found in the data set. The last output that I wanted to show you was of our smart sewer repair model. This is analyzing that PACP database and providing grades by codes, listing a variety of other information about the inspection data, and then also generating recommended repairs, the priority of those repairs, as well as the total price. Used internally within the KCI team for a medium-sized project, this smart sewer repair model was estimated to save 40 hours of analysis work, which is an incredible time savings. So now I think we've reached the point in our webinar where we can open it up for Q&A. We'd love to start answering any questions you might have.
If you have any questions, feel free to type your questions in the chat.
While people are chatting or typing in their questions, we did have a list of commonly asked questions about BRYX. One is, how do I start my free trial? Just go to gobryx.com, and perhaps, Jay, you can type that into the chat if you haven't already, and click the Get Started button, and then you're on your way. Free trials are completely free, no credit card required. Purchasing credits is something that can be done directly from the BRYX platform. So you just go to our pricing page and follow the instructions on how to purchase credits there. And we accept a variety of different credit card payments, including all the major ones: Visa, American Express, MasterCard, etc. Have we gotten any? Oh, great. We are getting questions now. So we got a question from Mike. Thank you, Mike. Is the model calibrated for various pipe materials and associated defects specific to those materials, from wood stave to PVC to VIT clay to concrete, etc.? I'm going to pass that question on to Carl, who is the originator of this model. He might have some insight on that.
Yep, that's a great question. Our data that we trained from did cover a number of different types of pipe materials. There wasn't anything specific built into the model, guiding the vision system, for example, based on the type of material. But it is limited to what we've seen, and we haven't seen every type of pipe, that's for sure. So yeah, that would be the short answer. I don't know if that answers your question completely or not, but.
Catherine, we have one more question. Does our system only do post inspections?
Good. That's a great question. So in this use case, our model is designed for processing videos after the inspection. We are not, it's really designed to optimize that QA/QC process of reviewing the coded video.
Okay, we have additional questions from Mike. Is it continuing to develop with the new pipe experience? Maybe Kyle, you can answer that.
Yeah, that's absolutely the intent. We have a process in our MLOps pipeline called active learning that users are able to participate in. They can help us improve the model by allowing us to do active learning on their data, which means that that data is then consumed by the training system to continuously improve the learning model.
And there's another question. How many PACP code does your system cover today?
Good question. Let me get a list so that you can see. We go to our catalog. It gives you all the common sewer defects that the model is currently trained to support. So I think that's about 17. Carl, does that sound right?
I think 23 or 20, something like that. And those defects were identified by our subject matter expert as their most frequent defects that they see. So that's how we focused our learning, training, and activity. As people probably appreciate, with 150 or so total codes, there's some distribution over that population of codes where there's some that are seen far more than others. So we tried to focus on the most common ones.
All right, so I'm going to get back to the slideshow if I can. And Jay, can you talk about next steps? Or
yes, so thank you again for joining the webinar today. As the session comes to a close, your journey with the BRYX SOAR model is just the beginning. So now you have seen what the BRYX SOAR model can do. So you might thinking, I want to upload my CCTV data into our SOAR model and see the result and see how much time you could save. So that being said, if you like to try out, feel free to reach out to me. You can see my contact information on the screen. And also I'll be reaching out to you by email and call. So therefore, if you receive any information from me, please reach out, please respond. And once again, thanks for your time, and I look forward to connect with you guys.
thank you all. Have a good day.